Okay, so now we're going to talk about section 2.2 in our book, which is all about the circle. So I know we all know the circle, the basic look of a circle, but let's talk about some details of it that will help as we progress. When you think about a circle, the centering of the circle and then the distance from that centering out to the edge of the circle, what really makes it the circle, the outside points along this, that's actually the circle, and it's a collection of points that have been plotted like we were doing in the last section. You could find XY coordinates that solve the equation and then graph it, and those are all the little points, and then we connect it to kind of fill it in and show the full circle. But this distance from the center out to the side is called the radius, so R for radius. And then the center of the circle, we'll use the letters H and K. This book uses H and K to designate the centering of a circle. So the general form for your notes of the center radius form of the equation for the circle is x minus h squared plus quantity y minus k squared equals r squared, where h and k is the center and r is the radius. So a simpler form of that, if you're centered at the origin, would just be x squared plus y squared equals r squared. This one has a center of 0, 0. So this would be this picture centered right there and then drawn around it. So it's centered at the origin and then there's some radius distant out. So if we had the equation x squared plus y squared equals 25, we would expect this to be a circle. It's in circle format here. So the center is at the origin. There's no h and k values that's offsetting that. And then this last number is the radius in its squared form. So the radius would just be 5. So we could graph this and say it starts at 0, and then the radius goes out 5 places all around it. So you could draw in a few like that and draw it more perfectly maybe than I did, but it's a distance of 5 away from whatever its centering is. So again, what makes me think this is a circle is when I see the x value is squared and the y value is squared in that format. Also to note, because there's variations on what we call conic sections, we only study the radius, the circle one of them, but there are other types of figures, like for example, an oval or an ellipse is a variation of this. So if these numbers were different, if this were a 1 and this were a 2, if you had different coefficients, it actually makes it lopsided. It's not going to be a perfect circle. So you need equal coefficients, which you will have on this section. These are just 1, so definitely equal coefficients. We're adding an x squared and a y squared equal to some constant squared. So you'll see a lot of that in this section already. That's what you should expect in your assignments. So if I had x squared plus y squared equals 64, I would know this is also a circle centered at the origin. Radius is 8. So I could sketch that in, starting at the center and then go 8, maybe that's 8, and then draw around it, and that would be the graph of your circle. Alright, so not always are they centered at the origin though, like we saw in the other format. It could be off-centered, like this picture. So then it looks like an x minus a number we call h, plus y minus some other number squared equals the radius squared. So here's an example of that. Let's say we had x minus 3 squared plus y plus 4 squared equals 9. I expect this to be a circle again because the x is squared, even though it has an offset. The y is squared equals to a positive constant squared. There are equal coefficients here, and that's how I know this should graph to be a circle. So from the formula, it says minus h, and then the center is at positive h, so it changes the sign of this number to positive 3, and the sign of this number to negative 4. So that will be my center. And then the radius is, this is the radius in its squared form, so we need to square root it to find the radius. So the radius will be 9. I'm sorry, the radius is 3, the square root of 9. And then we could graph this. The center starts over 3, down 4, and then the radius is 3 around from that. All right, let me give you a you try now. You can pause the video and work this one to think about it. Let's say we have x plus 1 squared plus y minus 4 squared equals 16. If you will graph that circle. All right, so the center is the opposite of what you see here, and again, that's because there's subtract signs in the formula. So the center will be changing that sign to -1, changing that sign to +4, and then the square root of this doesn't always have a perfect number here, by the way, but just to make it easier on us starting out, they're nice perfect squares. But say that was 18. We would say the radius is the square root of 18. We wouldn't leave it, we wouldn't be able to get a perfect answer. It'd be a little harder to graph, but we could do that. But just to make it easier here, nice numbers, back 1, up 4, and then the radius is 4, so 1, 2, 3, 4, 1, 2, 3, 4, and then we draw our circle around that, and that's how we would graph a circle. All right, let's see where I'm at in the book. You can also do it the opposite way. It'll say maybe find the equation of the circle with the center at say 3 and 4 and a radius of 2. Say it said to go the other way. We could find the equation. No, I could graph that as well if that were the directions, but the equation, I would know that it's x minus that number squared plus y minus this number squared equals the radius squared, so 4. So that's another way to write that, or to have this wording here going the other way. So the next thing we need to be able to do is, what if this is expanded? What if this equation were FOILed out in expanded form? X minus 3 were squared. Just to remind you, how do we square x minus 3? We can write it down twice and FOIL it, combining our middle parts. Or we can use the squaring pattern, the square of the first, the square of the last, and then times together and double the middle. So the binomial squared. But this is this in expanded form, and then this would be, and then the 4. So I could bring the 4 across. I would have x squared minus 6x plus 9 plus y squared. Let's see, and that's 12 equals 0. So this is our next step we're going to take, is what if you have a string of terms that looks like this, and you're asked to find the center radius form of that, to work backwards from the expanded form. How can you pull out where that center radius is? So what we're going to do is, first of all, talk about why we think it's a circle. It's because x is squared and y is squared, both with equal coefficients of +1. And the rest is a lot of gibberish around it, but that's what drives my decision to think it could be a circle, x squared and y squared. Just like just regular x and regular y makes a line, I know regular x squared and y squared, they're positive and equal coefficient, usually makes a circle. So I would try to work backwards from that and make it look like the center radius formula that we've been talking about. So to do so, sometimes you have to complete the square. And we learned a little bit about that back in chapter 1, and this is where it comes up again. So this one already has its squares completed, and I recognize that is a perfect square trinomial, so it factors back that way. So your ideal is you want to be able to find a perfect square trinomial for your x terms, and then do that again for your y terms. Well, problem is, this number is not always the right number that completes the square like this one does. The number that goes here needs to be half the middle term squared if it's a perfect square trinomial. So this one is, when we talked about, it came from that. But what if you would have had 7 there instead? That's not factorable. That's not going to get it to the right format. So what we do is we complete the square and make it that way. We throw the 7 to the other side, and then we add in the number we want to be there to make it work for us. All right, so let's look at an example of that. All right, I am on example 3 in your book. So I want to try to find the center and the radius of this circle. I think it's a circle because I have a 1x squared and a 1y squared. That's what drives my decision. Then I collect my x terms, kind of think of those together, and then collect my y terms. Maybe leave a space because I'm going to complete the square there. There's not even a number there now at all. This one has a number, 18. I'm going to throw that across the line and start fresh though, and that's kind of the recommendation on all these is just if there's numbers, constants, throw those across the line and start fresh and find your own number that completes these squares. So I have an 18, bring it over minus 18. Now, again, to complete the x's squared, and do these one at a time, the x's, then we'll do the y's, you half the middle term and square it. So half of 6 is 3, 3 squared is 9. 9 is the number that completes that square. If I add 9 to the left, I will need to compensate and add 9 to the right. We know that, right? You can't just add numbers randomly. You have to keep the balance. Now, why did I add 9? Because that makes that now factor. That's that x minus 3, x minus 3 that we wanted, or x minus 3 to the second. You can have faith in this process. If you've added in the right number, it will factor into this square root and that square rooted and this middle sign. It will always come down as a binomial squared if you've added in the right number. Now for the y's, think about this. We're completing the square for this quadratic part. Half of 10, and then square it. So what is half of 10 squared? Okay, so that is going to be our 25. Half of 10 is 5. 5 squared is 25. We add 25, so we've got to add 25 to the other side. What that means is this now has to factor. And again, you can have faith in this. It would be square root of the front and the back, and then the middle sign brought down. Now it's starting to look like that circle format. Then combine all your like terms over here on the other side, and that comes to, what does that come to? 16. So combine these on your calculator, and now it's where we started in this section. It's in that format to find the center is at 3, -5, so we change those signs, and the radius is the square root of this number 4. We could graph it if requested. Alright, I'm going to give you one to try, so you may want to pause the video and go through this process on your own. I encourage you to do that for your practice. Give yourself time to think about it a little bit and try it before coming back in. Alright, so here is your you try to repeat that process. Alright, so I'm going to collect my x's, collect my y's, and then any constants get thrown over to the other side. So we're starting fresh. So x squared plus 4x plus what completes that square? And we can only complete the square if there's a 1 coefficient. So that probably will have to be in the next video if that comes up. That scenario, we have to divide it out. But you need to have a 1 coefficient before you can use completing the square. But it's half the middle, which is 2. 2 squared is 4. That makes this now factored to x plus 2 to the second. Doing the y's the same way. We have y squared minus 8y. Half of 8 is 4. 4 squared is 16. I'm adding 16 to complete this square. Remember, it always factors into the square roots of each part and then the middle sign. Then lastly, over on this other side, I probably should have already brought that down. I brought my 44 across, and then I can't just add numbers in without compensating on the other side. So I've got to add the 4 and the 16 that I added extra here. I've got to add those to the right, and then combine all those like terms. Let's see, that is 64. Now I can see the circle format, -2. Positive 4 is my center with a radius of 8, the square root of 64.